Gadge, can you see the screen? Screen this thing?
Yes.
This thing. Okay, so yesterday we started with this part. What is microcontroller, comparison, family of microcontrollers. Okay, in family we have seen this one. Correct. Started with 8031, which is a ROM-less version of 8051 microcontroller. 8032, which is also ROM-less version, except that memory is enhanced. Instead of 128 byte, 256 bytes. Correct. 8051 you can see 128 bytes RAM memory, 4 kilobyte ROM memory, 2 timers or counters, 5 interrupt sources, and 1 serial port. That is the configuration for 8051. 8052, you have double RAM memory. Instead of 120 bytes, you get 256 bytes. ROM also, instead of 4 kilobytes, you get 8 kilobytes. Timers, 3 timers. Interrupt sources, 6, and 1 serial port. Correct. Other companies have also produced the microcontroller 8051, like Atmel. Their series starts with 8089C51. So that is same as 8051, except that instead of using EEPROM, that is ultraviolet erasable programmable memory, they are using flash memory, which is nothing but, flash memory is nothing but electrically erasable and programmable read-only memory. That yesterday we have discussed. Okay, then these are the important features of 8051. So what you see, 8-bit CPU, 16-bit program counter, 8-bit processor status word. Actually, it is program status word, PSW. Then that is flag register, we call it as. आपल्याला 8085 मध्ये आपण बघितलं होतं आपल्याकडे फ्लॅग रजिस्टर आहे ह्याला फ्लॅग रजिस्टरच्या ऐवजी इथं PSW म्हणतात. 8-bit stack pointer SP, internal RAM of 128 bytes, special function registers 128 bytes. हे मात्र extra feature आहे बरं, special function registers, which is not present in microprocessor. Microprocessor मध्ये असे स्पेशल फंक्शन रजिस्टर्स नाहीये जे मायक्रोकंट्रोलर मध्ये आहे. ठीक आहे. 32 पिन इनपुट आउटपुट, 8-bit parallel ports. Each port is 8-bit. So there are 4 ports, P0, P1, P2, and P3. 2 16-bit timers and counters, T0 and T1, they are named as. 2 external and 3 internal vectored interrupts. Okay, vectored interrupts means as soon as the interrupt comes or as soon as the interrupt occurs, the microcontroller will jump to the interrupt service routine. Interrupt service routine means whatever program we have written for that particular interrupt, for handling that interrupt or for servicing that interrupt, it will directly jump to that program and it will start executing that program. Okay, and after completing that program, it will come back to the original program where from it left. And one full duplex serial IO, that is important. Full duplex serial IO means you can send the data serially 1 bit at a time, and you can accept the data or receive the data serially 1 bit at a time. Okay, so that is called as full duplex. Full duplex means actually data transmission, serial data transmission, and serial data reception both can occur at a time simultaneously. Means the microcontroller is sending the data 1 bit at a time, as well as simultaneously it is also receiving the data from external peripheral. Correct. So both the things, transmission as well as reception, can occur simultaneously. That exactly means the full duplex mode. Okay, half duplex mode means it will when it is sending, it cannot receive. When it is receiving, it cannot send. That is called as half duplex. Correct. So there are simplex, half duplex, and full duplex modes. Simplex mode means you can only send the data, but you cannot receive the data. And other device will receive the data, but it cannot send the data. Okay, it is one-way traffic. So one-way traffic, we call it as simplex mode. Half duplex means I am sending the data, but simultaneously I cannot receive the data. But I can change the role. Okay. After some time I will receive the data, but I will not be able to send the data. So both the things, sending and receiving, cannot occur simultaneously at a time. Okay, it cannot occur at a time. That we call it as the half duplex mode. And full duplex mode means you can send the data as well as you can receive the data simultaneously. That is called as the full duplex. So this part we have seen, and we have started with the architecture of 8051 microcontroller. Okay, microcontroller is a very important device for us because it is mostly used in all the electronic appliances. Okay, microprocessor, as you know, will be used in only computer systems. But for other devices, for remaining applications, you can go for microcontroller. You don't need a microprocessor. Correct. So only for CPU, that is computers, we are opting for microprocessor. Whereas for all other applications, we are considering only the microcontrollers. Okay. And for our syllabus, they are given only the architecture of, that is a syllabus regarding the microcontroller 8051, which is the first member of the Intel family. Okay. So as you know, in robotics, in different home applications like washing machine, okay, MP3 players, set-top box, electric irons, ovens, electric ovens, everywhere we are using the microcontroller. Of course, there are some of these devices may have higher end microcontrollers. High-end microcontrollers means 16-bit, 32-bit microcontrollers. And lower end microcontrollers means 8-bit, 4-bit microcontrollers. They are called as lower end or low-end microcontrollers. Okay. We classify them as lower end or small scale, medium scale, and large scale. Correct. Small scale means 4-bit and 8-bit microcontrollers. Medium scale applications means 16-bit or 32-bit microcontrollers. And high-end applications means 32-bit or 64-bit microcontrollers we are using. Now this, here you can see the architecture of 8051 microcontroller. As you can see, what is there inside the microcontroller? Basic block diagram we already studied. Okay, in the basic block diagram we have shown there is a CPU, then there is a RAM, there is a ROM, there are timers. Okay, in the block format we have shown there is a bus control unit, there is a parallel IO unit where 4 ports, 8-bit parallel ports are used. Okay, one serial communication port is there. All these features and interrupt control, of course. Interrupt controlling unit is also there, included. So that we have seen in the block format. Okay, but when I consider the internal architecture of 8051, I have to specify it in more details. Okay, so these details are given in this particular block diagram. This is the internal block diagram of 8051. So what do you see in the block diagram? you can see there is a RAM. This is the RAM. It's 128 bytes. This is the ROM. This is 4 kilobytes. Correct? There are 4 ports, as you can see. This is port 0, which is a 8-bit port. This is port 2, which is also 8-bit port. Okay. As well as you can see, here you can see 2 ports. Port 1. This is port 1 and this is port 3. Okay. All the ports are 8-bit. As you can see, 8 wires are connected to these ports. So all these are 8-bit ports. So 4 ports are there. There are 4 ports. One is port 0, port 1, port 2, and port 3. So all the ports are shown here. Before the ports, you can see there are latches. Okay, whatever data we want to send to the port, actually it is sent to the latch. Why it is sent to the latch? Because whatever data you send, that is retrieved or that remains in the latch unless and until you change that data. Okay, so before you change the data, the previous data is already present in the latch. So that helps to keep the data as it is. Okay. So latches are generally used before the ports. So port 0 will have port 0 latch. Port 2 will have port 2 latch. Correct. Then here you can see there is a RAM and there is a ROM that I have told you. It is 128 byte RAM and 4 kilobyte ROM. That is the EEPROM. But it is ultraviolet erasable programming. Okay. For Intel 805. If you are using the Intel chip, then it is UV EEPROM, ultraviolet erasable programmable read-only memory. But when you consider Atmel series, this is another company. Then in that case, we call it as 8951. And it starts with 80. 80 for Atmel. Okay, so in this case, where the EEPROM is not UE EEPROM, it is EEPROM. EEPROM means electrically erasable and programmable read-only. That is very good. Electrically erasable and programmable read-only memory. So what is the difference between UEEPROM and EEPROM? UEEPROM, if you want to erase the previous data which is stored in the memory, then you have to take that chip, EEPROM chip, and allow the ultraviolet radiations to fall on its window. Okay, they will penetrate through the window, and those ultraviolet rays will erase the previous data which is present in the memory. But when are you so every time you want to change the data, you have to plug out the chip from its socket and take it to the UV eraser, that is the ultraviolet eraser, where ultraviolet radiations are there. Okay, it takes almost half an hour, 20 minutes minimum to erase that particular chip. Okay, and then again you have to take it to the programmer, where new data you can load into or program into that memory chip. So that is a troublesome work. Okay, every time you have to plug out that chip if you want to erase that data. Instead of that, if you go for EEPROM, electrically erasable programmable read-only memory, then you don't have to plug out the chip. Okay. Nowadays, in-system programming facilities provided. In-system programming means you don't have to change. You don't have to plug out the chip from the socket. Okay, you can program the chip within its applications. Okay, so a few pins are provided for programming purpose. Okay, and you have to connect the USB pin connector to that particular microcontroller card. Okay, where the programming pins have been brought out on the pin connectors. You have to just plug into those pins, and whenever you want to change the data, you can immediately change the data, change the program code within that microcontroller. Okay, while it is in the system. So you don't have to plug out the microcontroller chip from the system or application. Okay, you can send the data, you can change the data, you can change the program anytime you want. So that is the advantage of EEPROM or ISP program, in-system program. Okay, so the earlier versions of 89C51 or that Atmel series, where you have to plug out the chip, okay, and take it to the programmer, and in the programmer you can erase the previous data and you can burn the new data or new program. That facility was there, but nowadays some advanced work has been done by the Atmel, and they are now providing in-system programming facility. So in in-system programming, you don't have to plug out the chip from its application and put it into the programmer. Rather than that, you are providing the serial programming facility using the USB port. So through the PC, you can burn the code directly into the microcontroller without plugging out the chip from the application card. So that facility is provided by the Atmel, and that's it. That facility we call it as in-system programming. Okay, within the system also you can program that chip. Here you can see to address the RAM, there is a RAM address register. Okay, so RAM is 128 bytes. Okay, so it needs only 8-bit address. You need a 8-bit address. Correct? Because starting address will be 00000000. This is 8-bit, and last address will be 11111111. So in hexadecimal number system, I call this as 0, and this also as 0. 1111 is called as F, and this also as F. Your address starts at 00 hexadecimal and ends at FF. Correct. Now out of these, this makes it 256 bytes. It makes 256 bytes. Okay. Whenever you are using the 8-bit address, it is 2 raised to 8, and that is 256. So it can address 256 bytes. But actually our RAM is only 128 bytes. So our address will start from 00H and it will end at 7FH. This is exactly 128 bytes. And from 80H up to FFH, these are remaining 128 bytes, and they are used for addressing the SFRs, special function register, SFR. Okay, so you can address the special function registers. Every special function register has a unique address, and that address falls in this range, that is 80H to FFH. This is very important. None of the SFRs have address in the range 00 to 7F, because this is purely RAM area, user RAM area. Okay, it is not reserved for any SFR or for any special function registers. It is utilized by the user. Okay, that's why it's called as the user RAM. I think it is clear now. So RAM address register means the register which provides the addressing facility for the RAM. Then we have a very important unit that is called as the ALU, Arithmetic and Logical, ALU. So in the ALU, we can perform arithmetic and logical processing. In ALU, we can provide arithmetic and logical processing. Both the types of processing they are provided in this particular unit. Okay, arithmetic processing means addition, we can do subtraction, multiplication, division, increment, decrement. Okay, so all these are the arithmetic processes. All these processes we can be performed in the ALU. This is called as operating on the data. Okay, operating on data. Suppose there is a data 45H and 87H, and I want to add these two data values. Okay, 45H plus hexadecimal values plus 87H. Okay, so one value is taken in one register, another value is taken in another register, and we add these two values, and the result remains in the destination register. Correct. So one register is called as destination register, and one register is called as source register. So data is added from the source register into destination register, and the result is saved in the destination register. So this type of arithmetic operations we can perform in the ALU. As well as we can perform the logical operations. Suppose I want to AND the data, OR the data, XOR the data, XOR the data, no complement the data. Okay, all of you know the logical operation, complementing the data. All these logical operations you can perform on the 8-bit data, and that is again in the ALU. मस्के भीमा आवाज थोड़ा कमी कर. Okay, so for performing any arithmetic or logical operation, accumulator is the most important register which is involved in all the arithmetic and logical operations. Okay, so whatever operation you perform, one of the data values has to be in the accumulator. Second data value may be in the register, maybe in the bank register, or maybe in the register B, which is also another important register. Okay, if you are performing multiplication and division operations, then one data is in the accumulator and second data is compulsorily in the register B. But whenever you are performing other operations other than multiplication and division, like addition, subtraction, increment, decrement, in that case, the data has to be in, one of the data has to be in the accumulator. Second data can be in the registers, special function registers, or it can be in the bank registers. So all what is bank and other things we are going to study afterwards. So I'm just giving you the glance at what is the internal architecture of 8051. Okay, 8051 microcontroller also needs sometimes a temporary register, but these temporary registers are not accessible to the user. Means user cannot make use of these registers. I can make use of B register. I can make use of accumulator register, but I cannot make use of the temporary registers. Temporary registers are purely used by the microcontroller for temporary storage of the values or some data or some results. Okay, and they are not accessible to the user. Means user cannot use these registers. They are totally internal registers used by the microcontroller or used by the control unit. Correct? And as per the results in the ALU, as per the results of arithmetic operation or logical operations, the results are reflected in the flag register. The results get reflected in the flag register. For example, if the result is 0, then 0 flag will be set to 1. Okay, if I subtract, for example, 55 hexadecimal minus 55 hexadecimal, in that case, the result has to be 0. Okay, and then in that case, the 0 flag will be set to 1, showing that the result is 0. Instead of that, if I add two data values and if the result is exceeding FF, if the result is exceeding FF, in that case, what you can say? The carry flag will be generated. So carry flag will become 1. Okay. So when the carry flag will be raised to high or raised to 1, whenever the result is exceeding the FF value, hexadecimal FF value. And whenever the result is 0, in that case, the 0 flag will be set to 1. Similarly, there are other flags like parity flag, sign flag, auxiliary carry flag, which are used in the signed division or signed arithmetic. Auxiliary carry flag is used in the signed arithmetic. Okay, so all these flags are there in this particular flag register. This flag register, we call it as the PSW, Program Status Word Register. I think it is clear. This is the basic block diagram or internal architecture of your 8051. Still, you can see there are many other units which are remaining in this architecture. One is called as the program address register. This program address register, PAR, it is nothing but in microprocessor we call it as program counter. We call it as program counter. Okay, PC. What is the job of this PC, program counter? To provide the address, either 16-bit or 8-bit address. 8-bit or 16-bit address. That is the use of the program counter register. Okay, suppose I want to read the data from the memory. Then the question is, from which address you want to read the data? Okay, last time I told you that memory is just like a book. Okay, if it is a reference book, then we can only read the reference book. We cannot write into that. If it is a notebook, then we can read as well as we can write the data into that. So suppose I want to read the data from the memory. Then what I have to do is I have to send the address of the page from where I want to read the data. Because I have told you that memory is like a book. Now every book has many page numbers, and on each page number there is a data. So whenever I want to read the data, the first question is which page data you want to read. So you have to send the address of that page. And how that address is sent? It is on the program counter. Using the program counter, you can send the address. Okay, normally 16-bit address scheme is used, but sometimes 8-bit addressing is also used. Okay, Now, microcontroller is such a device that data transfer normally takes within the microcontroller chip. Okay, it rarely supports, or very few times it supports the external data transfer. Okay. For example, it has inbuilt 4 kilobyte ROM memory. Now, if I want to expand that memory, instead of 4 kilobyte, I want to increase it to 8 kilobytes. Then there are two options. One option is to go for the higher version of the microcontroller, which provides you the higher capacity of the ROM memory, which is already providing you 8 kilobyte memory. Okay, so either I have to change my version, go to the higher version and purchase that particular chip and increase my memory capacity. This is one option. Second option is you can add the memory chip into your controller. Okay, but by attaching it externally. There is an internal 4 kilobyte memory. I can attach external 4 kilobyte memory to that chip, microcontroller chip. And thus I can make it a 8 kilobyte memory totally. Okay, of which 4 kilobyte is an internal chip memory and 4 kilobyte is an external connected memory. So in this way, I can increase the capacity, memory capacity of the microcontroller. So whenever you are attaching the external memory chip or any other chip, then you have to connect it through the address bus, data bus, and control bus. Okay, which are the together they call it as the system bus. So system bus is nothing but address, data, and control bus. So all these three buses you have to connect to the microcontroller chip. Only then you can access the data from the memory, you can access the data from the ports, you can send the data to the timers, you can receive the data from the serial port. Okay, whatever data transfer you want to do, you can perform it externally. But in that case, you have to connect all these buses to all these supporting chips or external chips you are going to connect. That is very important. So normally, external data transfer is not supported by the microcontroller because we normally don't connect external chips to the microcontroller. Rather, we go for the higher version of the microcontrollers, which provides, suppose I want, there are 2 timers in the 8051, and I want 4 timers. In that case, I will search for the chip, microcontroller chip, which has 4 or 5 timers already inbuilt in the chip. Okay, so I can go for the higher version, next version of the microcontroller. Or the other option is to change the company also. Instead of Intel microcontroller, I can switch over to PIC microcontroller from Microchips. Okay, they provide you variety of microcontrollers. Okay, they can provide you 16 timers, 16 counters. Okay, so many stack pointers, so many data pointer registers, 2 program counters, like that. So variety of microcontrollers are available in the market. You can switch over from one microcontroller to another microcontroller, depending upon the need of your application. So that is very important. Buffers are provided because you are going to connect the buses to different chips if you are going to connect the external peripherals. So the buses should not get overloaded because of the excess sinking of the current. So buffers will provide an enhanced capacity to provide the extra current sinking. Even if you connect 2, 3, 4 devices or chips externally, then also your buffers, your data bus will not get overloaded because of the buffers. So buffers enhance the current capacity of your buses. PC incrementer, decrementer is an important thing because sometimes microcontroller wants to go to the earlier address by jumping from the present address into the earlier address. In that case, I have to load the program counter with the lower address value. So that can be done using the PC incrementer decrementer operation. Okay, here you can see program counter there. DPTR is another, just like a program counter. DPTR is just like a program counter. Okay, it is widely used whenever we are accessing the external memory chips, RAM or ROM. This DPTR, which is another alternative for the program counter, is widely used in the microcontroller programming. So here you can see all these program address register, buffer, PC incrementer, decrementer, program counter, and DPTR, which are the important parts of your microcontroller. Stack pointer is also shown here. There is a stack pointer. Stack pointer is normally used whenever you want to save the data temporarily for in the memory. Okay, because if I'm using the same registers, okay, if I'm using the bank register, for example, if I'm using some special function registers, and I want to use the same register again for one more programming purpose. In that case, the data within that within those special function registers need to be saved somewhere else. So where it is saved? It is saved normally in the stack memory. Stack memory is nothing but the end part of your RAM memory. Okay, this is your RAM memory, user RAM memory, starting from 00 up to 7F. So from maybe from 50 to 7F, this part I can reserve it for as a stack memory. I will use it as a stack memory. And this part, remaining part, I will use it as a user memory. Okay, so in this way I can bifurcate my RAM into two parts. Some part will be used as a stack memory part and remaining part as a user RAM. So in this stack memory, you can save your temporary data or whatever data is there in the special function registers or any data you want to save. You can save that data in the stack memory. Okay, and you can retrieve that data. Retrieve means you can recall back that data again whenever you want. Okay, so that data remains as it is, even if you are using those special function registers for a different application. Okay, I am switching over from one application to another application, or from one program to another program. And if the data in that special function register, even if it changes, okay, and now I want to come back to the first program again. So I want the original values which were there in the special function registers. So I can retrieve those values from the stack memory. So that is the best use of the stack memory. I will stop here. गाडगे सगळं हे समजलं का? थोडक्यात मी सांगितलं, अजून डिटेल मध्ये आपण हे केलेलं नाही. थोडक्यात सगळं सांगितलेलं आहे. थोर बोले. Okay, so we'll end the meeting here.